And then, obviously, there's a lot of baggage that come with you. That's why sometimes you have problems with acids and bases. It's ionic tables, and then also in grade 10, you did a number of reactions that you had to write formula for. Formula and equations for a number of reactions. That first one, acid and a reactive metal, and it always produces a salt and hydrogen gas. So this metal will bond to the chlorine, and then the hydrogen is free. Right. So that was that one. Second one, acid and a metal hydroxide. What do we actually call a metal hydroxide? A metal hydroxide is a base. Right. Tell me another name that we give to an acid-base reaction. Neutralization. So whenever they say we've got neutralization, you have to have acid and base. And also remember, neutralizations are always exothermic. Always exothermic. Right. Now with acids and bases, it's actually an ion exchange. The chlorine will go to the zinc to get zinc chlorine, and the hydrogen will bond to the OH, and you'll have water. So you should remember this from grade 10. But if you don't, just check it. Hi. And then what do I know about NH3? NH3 is my weird base. So with NH3, you don't have the plus water. Right. You only have the salt forming. There's no water over there. Right. And then acyl and metal oxide, same thing. Do an ion exchange. The positive of this one goes to the negative of that one. And the last one there, acid and metal carbonate. Carbonate, CO3. Now, if you look at that CO3, for me, if I look at that CO3, I actually see the CO2 in there. Can you see this got CO2 in there? Right. If you do an ion exchange, the zinc will bind to the chlorine to give you zinc chlorine, right? And the hydrogen and the carbon will actually form H2CO3. Can you see that? But once it forms, it immediately splits into more stable things. CO2 and H2O is very stable. How much water do we have on Earth? Lots and lots, right? Seas full of water. Why? Because it's very, very stable, right? So if it can form, it will form, right? So if you have an equation and you don't know what the products are, if there's H and O, I can sort of guarantee that H2O is going to form. And also CO2, right? Where do you find CO2? Right, CO2. There's a lot of CO2. Why? It's very stable, right? So you have to put them separately. They split immediately because they make more stable products. Right. Okay, I see you need to start doing something. So let's turn the page and go on to page 23. Now you're going to start working. On page 23, I'm asking you to write balanced equations for the following. We're going to write balanced equations for the following. So now I've mixed them up. You've got the grade 10 equations. Just turn back, grade 10 equations. Do you see there's no ions over there on the right-hand side? Because it does ion exchange, and you end up with nice new compounds, right? But if something reacts with water, if you've got an acid or a base, and it's reacting with water, then what type of reaction do I expect? Ionize or dissociate. And that means then I must end up with charges, right? I must end up with ions. So when you look at this, you have to identify this. Now the first one, they say ionization. They're giving it away. I must end with ions, right? Let's just do the first two and then you can go on. The first one, nitric acid in water. Nitric acid, you have to know the equation by the formula by heart, right? And then I also have to know nitric acid. It's an acid. What do I know about acids? They ionize. So should water go in the equation or not? It should be there because it's going to react with the water to form ions. Right. And how does an acid ionize? It is a proton donor. So it's going to give off an H+. Okay, is this a strong or a weak one? Strong. Ooh, yes, strong. Huh? The big one is to the right. It's strong. So I will end up with NO3 minus and H3O plus, and they are now both in solution. Right. And if you left out the plus and the minus, then they left out the mark. Right. So remember to put it there. Right. Second one, sodium hydroxide. Sodium is Na, hydroxide OA, 1 plus 1 minus, the formula is right. Okay. What do I know about sodium hydroxide? Strong base, right. What does a strong base do when it gets into water? Dissociates, right? So it's not going to react with the water. So for this one, you have to just put the water underneath the line. It's not going to make ions. The ions are already present, right? So it's just drifting apart. So the OH will go one way and the Na plus will go another way. So this is just dissociate, right? It's just dissociating. Then we get to the third one, oxalic acid. What does oxalic acid look like? Well, I prefer COOH2. Right, you might even do the other one if you want to, but this is the one that I prefer. And it is going to react with lithium oxide. Lithium is plus 1 ion, and oxide, 2 minus. So I have to take 2 lithium to 1 oxide, so I have 2 pluses for my 2 minuses over here. Right, if you've got problems writing the formula, you should make sure that you know this table of ions there at the back. Eh? So the lithium being plus 1 because it's in group 1, and the oxide being minus 2. So you need 2 lithium for 1 oxide. So there we are. Now, is this ionization, dissociation, ion exchange? Ion exchange, right. So what we will have is you've got an acid and a metal oxide. If you want to turn one back, acid and a metal oxide, what do I expect? Salt and water. Okay, so let's make a salt and water. So this one, the hydrogen will be given off, and it will bond to the lithium, COO. Hydrogen is plus 1, lithium is plus 1. It can just replace the hydrogen. Okay, but they will also mark it correct if you wrote Li2COO2. That would also have been taken as correct. Okay. So here they are very lenient, but you have to know what you're doing. Okay, so the lithium is going to there, and what's the other product? Water, water. Right, so now we don't up with no ions on the right-hand side. Ions on the right-hand side is only when it's in water, because then it dissociate or ionize. Okay, go on from number D. We number D, ammonia and water. Ammonia, the moment that you hear ammonia, you have little bells ringing, eh? This is the strange one, it does different things. Okay, so if that one is a base, what type of base? This is our covalent base, eh? And it's a weak one. If it's a covalent one, because it's non-metals, it will do the weird thing, it will ionize. So this is the only base that ionizes. And it means I have to put the water into my equation, right? And what happens? Now, how does a base ionize? A base is a proton acceptor. So the H plus is going to be donated to this one. So it's going to become NH4 plus in solution, and you will have OH minus in solution. Right. Next one, sulfuric acid. H2SO4. It's an acid, so what type of reaction do I expect with water? It will ionize, right. So I have to put the water into my equation. Right, now, if we look at H2SO4, can you see there's two hydrogens? It can give off two hydrogens. What do we call an acid that can give off two hydrogens? Diprotic, yes, diprotic. So this is diprotic. So it's actually going to react with two water molecules, and it will end up SO4 2 minus, because two H pluses went away, and then you will have two H3O plus ions, and you can say in solution, in solution. Now guys, there's a little bit confusion about this one. In reality, sulfuric acid is strong and it always gives off the first hydrogen. But then you end up with something that don't always give off the second one. So some teachers like you to write just giving off one. But for all the things that we have to do, all the pH calculations and so on, you have to take it for granted that both hydrogen is given off. So you will have to give off two hydrogen if you want to make use of this one for pH calculations. So it's like when we do electricity. With electricity, you know wires have got resistance. But when we do calculations on circuits, do you take that resistance into account? No, we ignore the wires and we just look at the resistors and the cells. Right. It's the same here. You have to do a little bit of making it easier to do. So what we're going to do is we're going to say if you work with H2SO4, usually you're going to give both hydrogen off, because then you can work out how many H3O pluses we are going to form. There's just one exception to this rule, and that is when they ask me to show the conjugated acids and bases. Now for this I need you to just look on the other side there at conjugated and bases. Remember you did that in grade 11. So let's just go back and see. Grade 11 we said if you had this equation, you can show which two is a conjugated pair. What is the difference between the two substances in a conjugated pair? They only differ by one H plus, right? So if you look at the left and the right hand side and you want to see who's the paired with this one, you look at the one that's only one H plus more or less. So this one and that one is a pair. Right, and then you also have to say this one is receiving an H plus, so this is a base. That one, if it reacts in the reverse reaction, what's it going to do? It's going to release, to give off an H. That's why that one is an acid. So this one is the base and that one is the conjugated acid, and they may only differ with one H plus. And then the same for water and OH minus. They may only differ with one H plus. So when you get to sulfuric acid, I will usually write giving off both hydrogens, because that's what we need when you do calculations. We have to assume they give off both. But if they ask you to indicate conjugated pairs, a pair may only differ with one H pair. Then I will write H2SO4 and only make it give off one of the hydrogen. Right, and then you end up with HSO4 minus. So if you are doing calculations, pH calculations, you assume they give off both. But if you have to indicate pairs, a pair may only differ with one H plus. Then this is an acid, and that is my conjugated base, and they are a pair, because they only differ with one H plus. Right, okay. So for this one now, I'm going to write 2. If you wrote 1, I think I will mark it correct. It depends on if you're going to do a calculation. You have to assume it's going to give off both. Right. So let's go on to the next one. Neutralization. What is neutralization? It's an acid and a base. Right. So you need an acid that needs to react with a base, and it produces. Produce means that's what I'm going to end up with. It produces potassium sulfate. Potassium, charge? +1 because it's in group 1, right? And sulfate, SO4, 2 minus. So I need 2 potassium for 1 sulfate, right? Every potassium is a plus, so I need 2 potassium so that I have 2 pluses to cancel out sulfates, 2 minuses. So potassium sulfate should look like that. Right, and neutralization. What is the other products that will form? We said neutralization is an acid and a hydroxide, and it will give salt and water. So the other product should be water, H2O. Right. And now, which acid, which base? And this is very important because we have to use it when we get to hydrolysis later on. How do I go back? Now, something is going to supply the sulfate, and something is going to supply the potassium. So actually what you're doing, you think about water as being an H and an OH minus, and then you just go back. This one is minus, so it will bind to that positive. This one is positive, so it will bind to that negative. And there you've got it. It should have been H2SO4 reacting with KOH. Right. So you have to be able to find the acid and the base that was used to produce this. But it's just sort of doing ion exchange in backwards way. Right. And now we have to balance it. 2 hydrogen, 1 sulfur, 4 oxygen, 5. Okay, but we need 2 of the potassium for 2 of the potassium over there. And then if we look at the hydrogens, we've now increased that, and there's 2 oxygen. So I have to put the 2 over there as well. So remember to just check if it's balanced. Happy? Right, let's move on. Ionization of oxalic acid in water. Oxalic acid, COOH. I hope by now you know it, even if you did not before today. Right? It's an acid. What type of reaction do I expect if it gets into water? Ionization. Right? It will ionize. So this time, water must be in the equation because I'm going to let it react with the water. Right. How does it ionize? Acid is a proton donor. And what do I have to remember with this one? It's going to donate both protons. So I have 2 waters that it will react to. One receive H from the one side of the molecule and the other from the other side. And I have 2 H3O+. And you may write in solution, in solution. Okay. It would have been fine if you chose to do the other one, the H2C2O4, and you had the C2O4 2 minus. Also correct. Right, next one. Reaction between lithium hydroxide. Lithium charge. Now it is 2 minus because 2 H plus left. Right. 1 H plus from the one side and 1 from the other. Remember that 2 means you've got 2 of these and each one is losing a H. Right. Good one. Everyone all right? Okay, so let's move on. Lithium, it was +1 because it's in group 1, right? And hydroxide, -1. So 1 lithium, 1 hydroxide, we're perfect. Now this one is reacting with water. Now before you put water, think, what is lithium hydroxide? It's a base, right? Actually a strong base. And what do we know about bases? Bases are going to dissociate except NH3, right? So if it's going to dissociate, don't put water in the equation. It's not going to react with the water. It's already got ions over there. It's just going to go apart. So the lithium is going to one side and the hydroxide is going the other way. Right. Very last one. Ammonia and hydrochloric acid. Nothing about water, so this is not an ionization or a dissociation, right? So what's happening here? This is an acid and that is a base. If an acid and a base react, we call that neutralization, and usually it gives a salt and water. But remember, NH3 does things different. So in this instance, this is the base, that is an acid. What a proton is the acid is a proton donor, base is a proton acceptor. So you're going to have a proton donated and accepted. And then you will end up with NH4 plus and Cl minus, or you may even put them together to give you NaCl. Right.